All right, students, I'm going to work through an example with you here. So go ahead and take a moment to please read the example that you see right here. And we see now Q1 is 2 coulombs, and then it doubles to become 4 coulombs. For Q2, we see that it's 2 coulombs, and it remains 2 coulombs. So no change there. And we also see that there's no change in the distance. We can label this distance as D. Sometimes we use R as well. Let's see, okay. And so we see that here as well, distance. Okay, so this Coulomb's law, I'm going to write out the equation. And the big thing here is that we're saying the electrostatic force. I'm going to use this symbol here, which means is proportional to Q1 and Q2, and is inversely proportional to the distance squared. So when we look at this here, we can see that Q1 goes from being 2 to 4, so we are doubling Q1. We're not seeing any change in Q2, so that here is no change. And for the distance, we're also seeing no change with that one. And keep in mind that because the distance is square here, we are going to be squaring that 1. So what changes are we ultimately making on the right side of this equation? We have a 2 times a 1 over a 1 square, which is equal to 2 over 1, which is equal to 2. So we're changing the right side by 2. That means we have to change the left side by 2 as well. So originally it was 18 units. Let's just throw in, let's just throw in newtons. So now it would become 36 newtons. And that would now be our answer. So to recap, because we doubled the force, the charge of Q1 is doubled. That had the effect of doubling the force, 18, to become 36. All right, now let's try another one here. And this one, we'll do number 3 on the bottom here. No, let's see here. Yeah, we'll do number, I think it's on the next page. Okay, so let's take a look at another example here. And this one is number 4. So here